Hi everyone. Hi Arijit.
Hi, Nikhil.
So everyone, thank you for joining for today's episode of MSME Masterclass. Uh, Unfortunately, Suman could not join us today as because of some personal emergency. But we have our in-house expert here, Mr. Arijit Chaudhury, who will be leading us in this conversation on the role of steel in EV manufacturing. And such, I welcome everybody to MSME Masterclass episode 17, where today we have a privilege of hosting Mr. Arijit Chaudhury, and seasoned professional with over 2 decades of experience in the steel sector. Arijit's career commenced at the prestigious JSW Dolby plant and has been across various steel manufacturing companies. Here in Dolby plant, he is instrumental in spearheading innovative research and development activities that have significantly contributed to the advancement in the space. Arijit holds a master's in technology degree from the renowned IIT Bombay, a testament to his profound technical knowledge and expertise. Over the years, Arijit has dedicated himself to exploring the frontiers of steel production and its applications, and driving numerous R&D initiatives towards great discoveries. Today, Arijit brings his vast experience and insights in a masterclass, aiming to enlighten us on the steel manufacturing space and the EV space and how they come together. Thank you, Arijit, for joining us today.
I'd like to thank Nikhil for introducing me, and thank you all the participants for attending this session with us.
That's great. That's great to put a face to the name. So, Arjit, aside from all the tech difficulties, let's kick off the session. To start out, I would like to ask, can you give us maybe an overview why steel is so pivotal in the manufacturing of electric vehicles, EVs, as it's commonly known as, and how does it compare to other materials used in EV production?
In today's world, electric vehicles are the things of the future. As I can tell you, like in main components of the electrical vehicle are basically electrical motors and car body, where we can use steel. So when you like to compare with other materials that is being used in the electrical motors like rare earth materials or carbon fiber or aluminium or magnesium, if you take, those materials are lightweight, but at the same time these materials are expensive as well and not readily available in the market. And when you compare with the steel is having equally higher strength. If you compare with this rare earth material, they are light but they don't have strength, but steel is actually having strength, so we can get higher strength to weight ratio if we use steel. So that's why steel is very useful when you are talking about making electrical vehicle. Like even if you use aluminium in the car body, the weight may reduce, but we cannot get strength out of aluminium or magnesium or any kind of alloy. So steel gives a good combination of weight and strength, as well as the ductility also. So that's why steel is a immediate choice for any kind of vehicle manufacturer, or especially for the electrical vehicle manufacturer, where we are actually thinking of saving the energy, saving the fuel.
Absolutely, as that's the primary main purpose with EVs, where
Correct.
energy efficiency and safety are a bigger priority.
Correct.
So, on the same path, now that we are talking about how it's really important, can we talk about how does steel enhances performance and safety of EVs, and how does the choice of material affect such said performance and safety?
See, if you're talking about the parameters which helps in increasing the safety of a vehicle, like the material should be strong, it should be ductile, it should be heat resistant, as well as it should be fatigue resistant. So whenever it will be on the run, so in that case cyclic load comes into picture, and in that way the fatigue strength becomes very, very important. So steel is having the combination of all. So steel is strong, steel is ductile, it is heat resistant, as well as it is fatigue resistant. So if we increase the strength, then it increases the toughness also. So in case of any kind of accident, if you are coming across any kind of accident or any kind of collision, so we need some impact strength. So that comes from the combination of strength and ductility. If you are UTS, like ultimate tensile strength is very high along with the good elongation property, so that will enhance your toughness. So that means the ability to absorb energy in case of any kind of collision. So in that way, steel will give you safety. Another way, any kind of steel, especially the steel which is being used in EV material or EV vehicle, so those are heat resistance also. So in case of any kind of fire incidents, steel can help in reducing the temperature and ensure the safety of a vehicle and safety of the passengers also. And if you are talking about the high strength to weight ratio, steel is having very good strength to weight ratio. So if you see 10% reduction in weight will result in 6 to 7% fuel reduction. So that means your performance will definitely better than any other vehicle or any other material.
Understandable, but as you were saying, right, the high strength steel has the best strength to weight ratio, which can save a lot of energy.
Absolutely.
Can you point out why, like maybe on an application or a chemical level, why is this achieving such ratios of weight to steel, strength to steel ratio, weight ratio?
See, I can tell you one thing. If you are using any kind of other metals, means non-ferrous metals like aluminum and magnesium, so they are having UTS or ultimate tensile strength of around 200 MPa maximum. But with the steel, we can achieve the strength of up to 1000 megapascal. So you can understand the difference. It's almost 5 times the regular non-ferrous materials, which we can term as a light metal. So in that way, we can reduce lots of weight. So see, steel is basically alloy between iron and carbon, and in we can add some silicon, chromium, manganese, nickel, cobalt, all to make it more stronger. So we can increase or decrease that UTS also, is ultimate tensile strength also. So there are lots of R&D works are going on to again improve the strength to weight ratio, so that it will be more safer, more energy efficient, less expensive option to the people.
Thank you. Thank you, Arijit. I think that kind of clarifies on that aspect. Since we are talking about the various aspects of steel, can you dwell into the quality dynamics of steel and explain its very crucial role in meeting the rigorous safety standards of electric vehicles?
Right. First thing I will tell, there are two types of steel are being used in the electric vehicle. Like the most importantly, the electric vehicles are using electrical steel, which none other vehicles are using. So that is the most important part of the electric vehicle steel. So if you are talking about because the quality parameters required for a electrical steel to operate properly is the magnetic permeability. So the magnetic permeability should be high, and there should be very low loss of the magnetic energy. So that's why we are using electrical steel. So if the magnetic flux generation is more, the running of the electrical vehicle will be smooth. So immediately it will give lots of safety and lots of good performance whenever it is in use. And again, whenever we are talking about that ultimate tensile strength, if you talk about the corrosion resistance, the heat resistance, those are the major quality parameters for any kind of electrical vehicle. So whenever we are talking about this kind of parameter, this can be achieved by a multi-phase kind of steel or dual steel. Lots of steels are coming up. So those kind of quality parameters are taken over by this kind of newly developed steel.
Understanding, so that the quality, such kind of aspects genuinely increases the quality. We understand that various aspects of steel giving us various aspects of quality through all of this. But here still, I'm not very clear on understanding of certain aspects of applications. So I would like to understand what are the various applications of such advanced steel grades that you're talking about in EVs, and EV manufacturing, and how can they contributing to enhancing vehicle safety, performance, and sustainability? And could you give some examples of certain advanced steels that are used?
Right. Like for the electrical steel, right now we are using a grade called high silicon non-grain oriented steel. So whenever we are using the term non-grain oriented, that means whenever the rotor is moving, because the electrical steels are used in the rotor portion of the motor. So whenever we are moving the car, so this is the moving steel. So whenever it is moving, so it can attract the electrical permeability from all the sides. So that is a new development. Earlier there is no such non-grain oriented technology. So now they are using a different technology to make it accessible from all the corners. So the permeability can be generated from all the sides. So your performance will enhance whenever it will run. So that is one point. Whenever you are using a different kind of steel, we are now using a different kind of steel, more stronger steel that we used before. This is called the dual phase steel in the car body. So here we can increase the strength from a regular carbon steel or regular alloy steel from 500 MPa up to 1200 or 1400 MPa as per our choice. So those steels contains a hard phase of martensite, and those are embedded on a soft matrix of ferrite. So this unique combination of a hard phase and a soft matrix will give you a better ductility as well as a very good strength. So this combination will improve the toughness of the material. As I spoke about the importance of toughness, whenever the vehicle can meet a accident, so this kind of dual phase is the best option for as a steel whenever you are talking about electric vehicle.
Understandable. So are these the only advanced steels which are utilized in this performance, or are there any kind of other steels left
So
over, or only these are the priority on
right.
EVs?
So these are the new steels which we have developed now, but now we are in a process to develop a steel advanced high strength steels. So here I spoke about the dual phase steel, where the number of phases are two. There is the option of multi phase steel, where there are different phase components of different strength level. Like the martensite is having the highest strength level of a phase. Then the second one is the benite. So benite is also there in the structure. Then comes the perlite, and then written austenite and ferrite. So all these used to stay together in the structure in case of advanced high strength steel. So that is also being manufactured by JSW Dolby and JSW Vijayanagar are manufacturing this kind of grades also. So R&D has been completed, and we are dispatching this kind of material to the customers also. So already all the research and development has been done. The most developed steel material that can be used for the electric vehicle. For other material or the other vehicle also, we can use this kind of steel, because in the electric vehicle we are basically emphasizing more on the energy saving. So it will give you the option of having more lightweight material. So your strength to weight ratio will be reduced, as well as your vehicle performance will improve.
Understandable, sir. So as the vehicle performance is increased based on the utilization of certain advanced steels, which is a very important factor. Sir, on continuing on this path, since we talked about how certain JSW plants and others have already initiated the material combinations that can be utilized in EV manufacturing, that are particularly exciting for the future of EV manufacturing.
Absolutely.
Especially in terms of, what do you think, sir? What are the latest innovations? Could you shed some light on them?
Like we are in case of electrical steel also, I spoke about earlier that now so far they're using electrical steel with the silicon content of around 3 to 4%. So now we are going for a electrical steel which is having silicon content of more than 6.5%. So if you are having silicon, your magnetic permeability will improve, as well as your the magnetic loss will be reduced. So your performance will increase. And again, we are going for a technology where the carbon can be reduced below 0.005%. So to do that, we need a very good vacuum level during the steel making operation. So very low carbon and high silicon electrical steel development is under progress. Like as I told you about there can be many grades of advanced high strength steel. This is not one grade, because we can by using different heat treatment technique, because some heating and cooling cycles, we can vary the proportion of the martensite, benite, ferrite and perlite, so that we can have lots of choices for our steel requirement. So that will depend on the manufacturer, and that will depend on the customer also, what kind of steel actually they want for their vehicle.
Makes sense, sir. But as you were talking about, right, the various various metals, martensite, ferrocite, and all of them. What do each of these components individually bring to the integrity of the steel in this factor?
See, martensite will bring the strength. Benite will be a good combination of strength and ductility. Whenever we are talking about ferrite will bring the ductility of the material. So in combination of all, we'll have a very strong and very ductile material, because the deformation should be there with the high strength. So the steel has to be flexible when we are fabricating, and whenever it will meet the collision, it should absorb the energy. That is the whole idea. So for doing that, we need the best combination of strength and ductility. Like strength of above 1400 MPa, we are now targeting for, with the elongation of more than 25%. So that will significantly improve the toughness of the material, or the energy observation ability of the material. So which is not available with any other materials we have spoken about, like the carbon fiber, aluminium, magnesium. Whenever you are talking about those elements, these elements do not have any kind of ultimate tensile strength. Those elements can be light, they might be having good formability, but the strength part they are not having, and you cannot have that kind of flexibility in selecting the materials. So they will be having only one kind of property, but in steel you can always customize your product as per the requirement of the market.
Yes, absolutely. In between, you were mentioning that the high strength steels at a max of 1400 MPa. Am I right?
Yes.
Why, is there a reason, or because I'm not very familiar with it? What about high strength beyond 1400? Is that not usable in EV manufacturing space? Yeah.
No, that is absolutely usable. So that's why we are developing a steel with very high strength, so that we can again increase the strength to weight ratio. So we can use more lighter material for that. So our energy saving will be better. And at the same time, if we get higher strength with good ductility, then your energy observing ability will be improved. Like what happens? There is an inverse relationship between the strength and ductility. Whenever you are having good strength, your ductility, we are actually compromising on the ductility. But if you have good strength with similar ductility level, your performance definitely will improve.
Understandable, sir. I think that kind of wraps up on questions from my end. We got a couple of questions from our audience before the session.
Yes.
So I think I'll try to cover those questions.
Yes.
While we do that, if anybody in the audience here right now present would like to ask any questions, you can drop them in the Q&A section. And as a joke, I think we can start with someone called Francis, who asked, when will it start? So I think, that's where everybody of you can post some questions.
Yes, surely.
Do that. Mr. Himanshu Sharma from Sharma Enterprise has a question on if I want to get into EV manufacturing space, what kind of ROI can I be expecting? And with such new changes in steel, what should I be looking ahead when I get started with this business?
In terms of steel, you are talking about?
In manufacturing and steel.
Right. So, first thing is, you only need to have a steel plant. That's all. Because the steel can be manufactured with any kind of process. Like the JSW is making the steel, with, they are having the blast furnace. They are having means steel making furnaces and the continuous casting machines. So only difference between the electrical steel or any other steel is the how much alloying element you are making. So with the regular steel plant also, which are making the mild steel as well the regular alloy steel, the electrical steel also can be made or any or can be developed. So no special means requirement is there for as far as steel making is concerned. Only the different alloying elements you have to add. That needs a good R&D team. That's all.
Understandable. Good R&D. So, sir, on that follow-up question only, I wanted to know, as I just know the basic, some grades of steel like mild steel, HR, CR, and such,
Correct.
and they go through the same manufacturing process through a blast furnace, I believe. Initial stages when CR gets again reheated and then cold rolled. What do we need different manufacturing equipment compared to what we would require for regular steel than for advanced steel that you would require to build for EVs?
See, as far as steel making is concerned, no changes required. Only thing you need specific heat treatment cycles. All the steel makers are having heat treatment furnaces. Only thing they need a specific heat treatment cycle for getting the exact proportion of the martensite, benite, ferrite, and all. So you need to have a specific heat treatment cycle. The recipe of a heat treatment that will only differ. Everything will remain same. Already I received some questions from Mr. Satish Korale, which grade are JSW developing for EV, for which parts manufacturing we are targeting these grades, I mean in vehicles. So already I told you, sir, we have already developed dual phase steel, and now we are in a process to develop different grades of advanced high strength steels in different proportions of because as per the customized requirement of steel. So whatever property you may require, we can manufacture. So these are advanced high strength steel we are making. So can we make an electrical three-wheeler outer body which this electrical steel? No, actually electrical steel is being used. This is a question from Mr. Yashwant Ramana. It's like that. Can we make an electrical three-wheeler outer body which this steel? So my answer is like that. We can make electrical. We can use electrical steel with electrical motors, not for the outer body. For outer body, you can use dual phase steel. You can use advanced steel also, or for your means three-wheeler requirement, maybe the regular alloy steel or regular carbon steel or regular mild steel which is in use in HR condition or CR condition, you can use. It's not a problem. Only difference is the electrical steel which will be used in the electrical motors.
I believe that kind of answers Mr. Yashwant's questions, and I think we're getting interesting questions. There was one more question I gotten from Mr. Vaibhav from Gupta Engineering. Is that what do you believe in the future of EV? Not in just manufacturing, but in the future of EV scope in India, since it still is in the initial stages. How far do you think EV vehicles will go? Will it go to like trucks, even till trucks business? Every other vehicle in India, do you think will become EV? What are your thoughts on that?
Actually, right now we are observing lots of EV vehicles around the cities, but the problem is like that we are not having enough charging stations. So first we need to have lots of charging stations across the roads, and we need to have charging stations in our houses also, because the people like us, we are actually living in the cities. So in our societies we don't have that much charging stations. So definitely I told you that EV is the thing of future. Like we are already depleting on our natural resources, and we have become more aware on the environment. So for that, electrical vehicles are very, very essential for our lives, for our future generation also. But we have to create that kind of infrastructure across the city, across our villages, across India. to make it sustainable. But we are basically ready with the technology. But I can tell you, so that kind of infrastructure has to be developed by the countries who wants to make it more energy
True,
saving. Yes.
True, as the ecosystem and the infrastructure grows, is then when we might be able to see the true potential of EV vehicles in India
Yes.
and
So,
how better we have fuel consumption and utilization.
Right.
It's a lot of
So,
scope.
Mr. Gupta has already sent me a question that I want to how to government incentives or subsidy influence the adoption of electric vehicles. Definitely, definitely it will help.
Absolutely, I
So
think
there
that
is a tax benefit. Definitely, we'll go for electric vehicles in future. But first thing, we need to have that kind of infrastructure in our houses, in the streets, same as the diesel and petrol we are getting at CNG we are getting.
yes, absolutely. I think that answers Mr. Gupta's questions, and I think maybe we got one more question. I think that was the question Mr. Somesh Gupta's, right, on the government incentives. Yes. I think that answers Mr. Gupta and other Mr. Gupta's question. So I think that kind of wraps up. I don't have any other questions, sir. What I want to say is really thank you for sparing your time today. It's been a valuable and insightful session on understanding of the composition of steels, which are the advanced steels which are used in the EV, to the various aspects of how it brings the safety and the performance of these EV vehicles. As there's so much scope for the steel role in the EV as it keep on growing from the batteries, safety, durability, and performance. We hope together to see a great future of India with a lot of EV vehicles. And with that, I think the session comes to the end. Thank you everybody for joining us today.
Thank you, Nikhil, and thank you all for joining us and giving this space to give you some idea about the electrical steel. If it is helpful to you, so that is absolutely satisfactory for all of us.
If anybody have any doubts or like someone wanted to know about EV or the materials used, if anybody wants to reach out to Arijit, you can all reach out to me. My email will be shared with every one of you in the post the event. So thank you everyone joining. Thank you Arijit ji.
Thank you Nikhil, and thank you all.